Improper integrals. Like I said, these are they're kind of weird to think about. We're integrating over an infinite space, all right?
You can solve it.
But we're still going to get an area calculation, right? Does it make sense?
Okay, yeah, that
right?
makes sense.
So if I graphed something like, let's say calculate the integral from 1 to infinity, right, of 1 over x cubed.
Oh, X.
Okay. Obviously, it's kind of weird to think that we're going to get an area from some big infinite space, right? But what you got to think about, and mathematics is, you know, in high school people say, well, there's always a right answer and all this stuff, and you really discover when you get into advanced math that there's a lot of fluidity in it. You kind of have to think through things not in such a concrete manner sometimes. So 1 over x cubed, I think it looks like that. And if we go from 1 to infinity,
And eventually it gets so close to 0 it doesn't make any difference.
exactly. It gets so close to the x-axis we're basically not adding any area. You know, you're basically adding 0.00 with a million zeros and a 1 area to it. Is that going to make any difference? No, it's not. So the area here is what we call is convergent, or it converges. Okay, so that's a word that we're going to really focus on this quarter, is converges. So what that means is that this infinite integral has an answer. Okay. Make sense? Kind of funny to think about an infinite length that actually converges, but somebody has something going on. All right, let's see. So how do we calculate this integral? Obviously, we can't put infinity in an integral as a definite number, right? So we have to actually, there's a theorem. I'm not going to subject you to the theorem, except that you know how to use it. But there's a theorem that says if we make the integral a definite integral, just put an r in it or some variable, but then at the end we'll calculate the limit as r approaches infinity. That we can do. Okay. So it's basically one step more than you already know, is all it is. Right? So we calculate the integral. That's x to the negative 3. What is the integral antiderivative?
1 over 2x squared.
Right? Or what you said. 1 over 2x squared. Negative. Okay, so we can evaluate that, right? So we get negative 1 over 2 r squared minus negative 1 over 2 times 1 squared, right? So now we're going to use our limit. So the limit as r approaches infinity of negative 1 over 2r squared plus 1 over 2, right? What is that? It's an infinite limit. What does this value become when we calculate this limit? 0, right? Yeah, so that's 0 plus 1/2. We get 1/2. Lo and behold, an infinitely long integral, it becomes the solid answer. Right. Okay, so that integral, what we call converges. Okay. If this gives us infinity, we would say it diverges. It converges and diverges. So this one actually converges Yeah, you put infinity in the bottom of a fraction. Where does that fraction head to? 0, right? That's just an infinite limit. Right, here's how we usually do it. The limit as x approaches infinity of 1 over x. Right? 0. Same thing. Yeah. So you're just drawing on your infinite limit knowledge to solve those problems is all it is. Here's another one. Here's another way the book will word it. Determine whether the integral from negative infinity to negative 1, 1 over x converges. Basically just telling you solve the integral, right? Calculate the numeric value of that integral. We took r, what's r going to approach this time? With our limit? Yeah. So the limit as r approaches negative infinity. Right. And then solve it just like we did the last one. Okay, so what is that? What's the integral of 1 over x? Right? Made 1 to r. We'll stick this out there. Some people drop this, work it, and then put it back like you did the last one. And some people keep it the whole way. If you're going to put an equal sign between these two, they need to have everything in it. But if you notice that I didn't put an equal sign here, right? So just be careful, it's a notational thing. No spelling errors in calculus, please.
Can you put an equal sign, like, on your answer because it's a definite answer?
Yeah, you can. Okay. What happens to natural log r? As r approaches negative infinity. It's absolute value, right? So what's natural log at infinity? What's happening? Do you remember what do you remember what natural log's graph looks like? What's happening is as we're going to infinity. What's happening to the y value? Yeah, it is. So this is actually infinite, right? So natural log at 1 is 0. So we actually get negative infinity for that limit.
Does that mean it's downward?
Yeah. Yeah. So therefore, you guys have seen that notation before? Have you? Yeah. Therefore, this here diverges. Okay. So, a couple different situations you might run against. And notice we're only dealing with infinite endpoints right now. That's Tuesday we're going to deal with infinite discontinuities.
How does that even work? How could something be infinite discontinuity?
You'll see.
Discontinuous.
Let's try one more here. Practice our.
At least you have students that actually learn it.
Yeah, no, I'm glad. This is a fun class to teach. You get to ask those questions. And I can actually spew some of my philosophy at you if you understand. Logic. Okay, that's good. All right. Look at this bad boy. Of course, we're going to rewrite it with R in it, right? And then how are we going to solve that integral? Integration by parts, yeah. So what are we going to choose as our u value? Yeah. So choose x as u because it's going to give us a u prime of 1, which makes life easy. And then v prime is e to the negative x, which makes v, yeah. Yep.
No, but for b prime, when you do negative e to the negative x.
Yeah.
V prime? Why?
For b prime, you just take straight down.
Yeah, v prime is that right there.
Oh, okay, so you don't even have to derive that.
No, you are grabbing a u value and a v prime.
Okay, sure.
Yeah, so you got the opposites,
Okay.
and then you calculate the opposites. Yeah. What's the formula?
Super voodoo.
Okay, that's part of it.
Ultraviolet super voodoo.
And the do, remember that's u prime, right? Okay, so uv is x e to the negative x minus negative e to the negative x times 1, yay, dx. And let's not forget this. Okay. So the limit as r approaches infinity. Is that e to the negative x? Is that right? The integral antiderivative?
Shouldn't the x and b like be negative?
The x is negative.
Yeah, but we determined b was negative because when you got the value at 1 negative.
I did multiply it by negative, that's why it's positive.
I'm taking the other side.
Oh, this?
Yeah.
uv? Yep. Thanks. Something's just not right here. I just don't know what it is. So check it. Okay. Okay. I just can't come soon enough. Who are you playing tonight? I always rewrite these with the exponents that are negatives since it becomes very obvious, right? What does this converge to? If I plug r in, so I'm going to have the limit as r approaches infinity of negative r over e to the r minus 1 over e to the r, and then plug 0 in. We get
So the first part converges to 0.
pretty sure.
No, but that's what you said last time when we
Yeah, but there's a top one. If I plug infinity in, I get infinity over infinity, right? It's indeterminate, so what can I use to algebra or L'Hopital's rule? Yeah, so you're going to get infinity over infinity here as an indeterminate form when you plug that in. Obviously, this is 0, right? But we need to L'Hopital's rule this and recompute. We get -1 over e to the r, and that's going to be 0, right?
I was right again.
You were right. Minus -1, so it's going to be 1.
What is that second fraction supposed to be?
This, 1 over e to the r, plugged r into this one. So one way to kind of avoid, so this is where I was telling you that math gets kind of like, it's not definite sometimes. You can think through this without doing L'Hopital's rule. Which one of those grows faster, r or e to the r? Very much so, because it's an exponential to the infinite power, right? So I could have told you right here this was 0.
Wait, so.
If you want to be more concrete, you can get the indeterminate form, do L'Hopital's rule. Okay, but you can think through these type of problems without being really concrete. You can be a little more abstract.
So I'm confused.
Okay,
How?
that's a first.
Why does it go towards 0 if there's infinity on the bottom?
Oh, well, you're divided. So what's 1 divided by 10? 0.1, right? What's 1 divided by 100?
I got it.
Right? Where are you headed? 0.0000, and it's going to get really close to 0 eventually. It just might as well be 0. Okay. Good question. Any others? Brilliant. I'm good. As in done. Not as in I'm good, but I'm done.
You're not trying to brag.
No.
Not this
That's
time.
what after the best part.
That is, oh,
I can't wait.
I-
Every time I hear this, something stupid, we're all going to stand up when our team go, do you have a brain? Because that's what he tells us every day of our life.
that's
I'm
going to
just
be
gonna
funny.
cheer as
And
loud
he
as I
chases
can.
us down the
You
side
got to
of
get
the
the
road.
whole senior class to say it or something.
Yeah,
Like, seriously.
Yeah,
because he yells at us every time we make a pass or take a shot, and he yells really, really bad.
It-
"You have a
I can
brain!"
just tell you
And
right
runs
now,
down the sideline, like chases us down the sideline.
it's going to be cleaner than last year, but I think it's going to be pretty stinking
Didn't
ugly.
someone tackle Mr. Bruder last?
I hope so with stuff like your like this stuff.
Are you saying something about
That
somebody?
was a question.
That was not an innocent question. I ran her over hard. Yeah.
Did you know?
Did
That was-
someone like
okay.
slam their elbow on your face though?
Me?
Or maybe that was. Mr. Jackson has the most legendary things of all time.
It was so ugly. I couldn't, like, normally, like with people that even have played basketball before, you can kind of get in a rhythm and still play. I was like, I'm open. Why'd you shoot a 3 from out there? Or playing defense, they're like, it was just like, I can't play like this.
Is Tyler playing again this year?
Tyler is playing, yeah.
I love Tyler.
I'm just excited.
It's going to be fun. I'm excited. It's just, I know it's going to be a little ugly at times.
But this is the fun